This is a screencast to show you something called what I call the bulletproof method for mole ratios, and this will help you with stoichiometry, or when you're measuring quantities in balanced chemical reactions, which is really the heart of chemistry, certainly in senior chemistry. And I'll just take you through the steps. So I'll do two examples, and you'll learn some of that principle. So we're working on this is a precipitation reaction, particularly working with solutions, which is what we've been doing lately. And I'll just read it through. The precipitation reactions occur, two soluble reactants mix, and you get an insoluble product. And that's called a precipitate. So the question is, what mass of barium sulfate is produced when 100 mils of a 1.25 molar solution of barium nitrate reacts completely with sodium sulfate solution? And let me just see if I can get this working. So the first thing you need is a balanced chemical equation, and that's really the heart of this whole process. So firstly you've got to write your chemical formulas, and you've got to balance it. So in this case, once you've got the formulas, make sure that there's a 2 outside the sodium nitrates to make sure everything balances. Why are we so pedantic about balanced chemical equations? Because if you look at a chemical reaction, it's all about the number of atoms that react. If you've got masses, if you've got volumes, that's no good. Why? Because different atoms weigh different amounts, and different solutions have different concentrations of atoms present. And a wise man once said, when atoms speak to each other, they speak in moles. And a follow-up to that is basically, when in doubt, convert to moles, because that's basically what the guts of chemistry is all about. We're talking about individual atoms, not masses, not volumes, not anything else. The balanced chemical equation requires things in numbers of atoms, or moles. Okay, and so we've got a measurement in this one which is a liquid, and we're going to use this C equals N on V equation. That's the mole equation that we know relating to concentration and volume. Okay, we'll work through that. So that's the one I remember, C equals N on V, and I just rearrange that because I'm interested in converting to moles, of course. So N equals VC. I write the volume, which is in mils, and remember the standard is litres, so divide by 1,000 to get it in litres, and the concentration is 1.52. And you work that out, and you get an answer of 0.152 mole of barium nitrate. Yep, NO3, 2. So that's how many in terms of atoms, the amount of material that you're working with when you're using barium nitrate solution. Now you want to the question. You always go back to the question. You're asking for what mass of barium sulfate is produced. So you've got to go back and try to get a mass. And there's a relationship between the two. It's the mole ratio. And mole ratios allow you to calculate how much of a chemical reacts. And this is the bulletproof method for doing that. You will not get confused if you use this method. So you take the chemical equation and you simply write the number of moles of a particular one of the reactants or products divided by its coefficient. So there's a 1, well, it's not written, but there's a 1 outside the barium nitrate, so you put the 1 on the bottom. And then you separate each component by an equal sign. So sodium sulfate, there's a 1 out the front, that's on the bottom. Don't worry about the arrow, just an equal sign is fine. Barium sulfate, again, over 1. In this case, the sodium nitrate is over 2. That is your saving formula, okay? And so now you can take any element of that and use it to help you with the calculations. So let's do that. We take the part that we like, that's useful to us. So the two parts that we're interested in are the barium nitrate over its coefficient and the barium sulfate over its coefficient. Substitute in the numbers, so we calculated that it was that many moles of barium nitrate, and we don't know this one yet. And in this case it's very straightforward. We can say that the amount, or the number of moles of barium sulfate is equal to 0.152 mole, which is not that astounding. It's the same as the other one, but that's just helps us get that clear in our head. So the next step then is to convert that moles to mass. And if you're talking about mass now, because it's asking for the mass that's required, you need the mass formula, and the one that we know is M equals M on M. You can rearrange that to be M equals NM, and then substitute in. Okay, so for the we're trying to work out barium sulfate. We've just shown using that bulletproof method that we have 0.152 moles of barium sulfate. Using our periodic table, we can work out that the molar mass is 233.4. Multiply those together and we get 34.5 grams, and that's to 3 significant figures. And that's the first part. Okay, let's do another example. So here's what if you get a volume of 0.1 molar sulfuric acid reacting completely with 17.8 mils of 0.150 molar potassium hydroxide. What do we do? Well, of course, the first thing we do is write a balanced chemical equation to set that question up. Because we're talking about a reaction, so that's the only way we're going to understand it completely. We've been given one volume, and we want to do another volume, but it doesn't help us with the equation. We first need all our quantities in moles. That's how equations work, in moles, or individual atoms. Again, we want the formula for that relates to concentration and volume. Okay, rearrange that again, and we substitute in the values. So we've got 17.8 mils, so we're going to convert that to litres, and the concentration 0.150 molar, and work that out, and that gives us 0.00267 mole of potassium hydroxide in that solution. Now, we use our bulletproof method for mole ratios. Take that equation, rewrite it as a series of equalities, okay, putting a coefficient each time at the bottom. So 2 for potassium hydroxide on the bottom, 1 for sulfuric acid, 1 for potassium sulfate, and 2 for water, okay? And then we pick the part of that set that helps us, which is the part relating potassium hydroxide and sulfuric acid, and then we substitute values in. Okay, so we've worked out that we had 0.00267 mole potassium hydroxide over 2. We don't know sulfuric acid number of moles. The ratio is 1, and so that gives us the number of moles of H2SO4 is equal to 0.00134 mole. And we're just about there. So we've got moles, that's good. The next step is we want to convert that back to volume. Okay, so we're using a volume equation. Rearrange it to get the volume as the subject, and substitute in that amount of moles that we calculated from the mole ratios. So it's 0.00134. Concentration was 0.1. and press some buttons, and we've got an answer. And remember that volume, the standard measure of volume, or standard units, is litres. Okay, so if we multiply that by 1,000, we'll get it to mils. So that could also be written as 13.4 mils. And there you have your answer. Hopefully that was helpful, and you'll be able to apply that as soon as you have a balanced chemical equation. That's where you should be thinking to go, so you don't get confused. Good luck.